This is part 2 of logarithms. Again, I want to remind you, here are the definitions that are given that b has to be positive, that is greater than 0, or not 1. A has to be positive also, can't have negative numbers there, and cannot have 0. So here's a couple of illustrations of that cannot be, and you'll get domain error. On the right side is, again, some of the log rules that we'll be using to be able to solve some equations and then spend a lot of time just solving equations. We left off last time trying to solve equations using some of these logarithm rules right here, especially these first three, and then we're going to use them for graphing. The log base 4 of 256, well, that would be an unknown quantity to us except for this third rule here where you have the same bases, and 256 can actually be written as 4 to the 4th power. Don't need a calculator for this one, you just need the log rule, and that means the solution is 4. Try that again, log base 4 of 2. Well, you'll have to wonder, can 2 be written in a base 4 to be able to match this 4 right here? Well, after a little thinking here, you might be able to determine that 4 to the 1/2 power, remember 1/2 is a square root, 1/3 is a cubed root, so 4 to the 1/2 power is really the square root of 4, which is 2. So we've managed to rewrite 2 in a base 4 as square root or 1/2 power. So according to this third rule here, the log base b of b to the n is n. Our solution here works. So I want to apply this now to logarithm graphing in the form y equals a log base b of x minus h plus k. This may remind you of a, h, and k that has been a theme all along. And I also want to remind you that a logarithm graph is similar, rememberable, to a falling tree. So if we think of a here, if a is positive, that means the logarithm graph would wrap over the x-axis and reflect over the x-axis as an x-axis flip. You'll also notice that x equals h is the vertical asymptote. Normally that's x equals 0, as in this first case. And when we apply these logarithm rules up here at the top, these are the 3 basic logarithm rules. We'll apply those. When I want to graph in log base 3, I want to pick numbers that are friendly to base 3. So an example of that might be maybe -3. But remember, according to our logarithm rule, a -3 is not allowed. You can't have a negative number there. So it's not a real number, it's an I number. So that's not on the graph. If I try 0, well, 0 is not possible to have there either. That is an I answer, and actually that turns out to be my vertical asymptote right there at x equals 0. And that's not a part of the graph, but it is a boundary on the graph. And then I try 1. Now that's this first log rule up here. Log base 3 of 1 is 0. So that's a dot right here on the graph. And then I try 3. Now 3 is a good number because it's base 3. I don't want to pick 2 because 2 would be hard to find. I'll pick 3. So the log base 3 of 3 to the 1st power is 1. So that would be the point right here. The next point would be 3 squared, which is 9. Let's pick easy numbers because the log base 3, that's this rule again, of 3 squared is 9, is 2. So the graph would show that kind of out here off of the graph. And the last one we're going to pick is a little weird, and that's 1/3. You see, 1/3 can be written as 3 to the negative 1 power. That makes it a base 3. And the log base 3 of 3 to the negative 1 is negative 1. And that would put a dot right here. Now, if I could connect these, I would draw my graph something along this line. See if we can do this. And on out to here, that's my base 3 logarithm graph. There we go. And it looks something like that. Let's go to the next graph. This was a base 3. And we want to make choices that make this easy. So now we're going to do a base 5. I hope by now that you're getting the idea that a base negative 5, 5, and negative 5, a negative cannot be allowed. That's a non-real number, so it won't show on the graph. 0 is the vertical asymptote, so there's the vertical asymptote. Again, log base 5 of 1 is 0. There's that spot on the graph. Log base 5 of 5 is 1. There's that dot on the graph. 25 picked is log base 5 of 5 squared, which is 2. Of course, that's way out there. I didn't even get that on the graph. 1/5 is the last one, which is 5 to the negative 1. And according to our third log rule there, the answer is negative 1. So again, if I was drawing a graph of this, it would look something like, see if we can draw this now, something like this. Oops, not doing very good on this one. And it would go way out there and hit that point. Just kind of get the idea there. So a log graph looks like it's falling. A log, a tree, is falling. So pick easy numbers for x, and then y is easy. So we use these 3 logarithm rules to emphasize this. The last graphing example is a little bit more complicated. And this one is base 4 of x plus 3. We're still going to use these logarithm rules, but it will be more thinking. Think of this. If I pick negative 3 here, that will make this thing come out in here, this quantity is 0. That would be my vertical asymptote. So this is an h shift, which is 3 to the left. So I pick a number that will help me find the vertical asymptote and get a 0 here. The next number that I do here is actually a little equation solver. It's x plus 3 equals 1. You see, I want this number to be a 1 because I know what log base 4 of 1 is. So I do a little calculation there, and I discover that this should be x equals negative 2. So I put a negative 2 there, and that gives me negative 2, 0. Next, I take x plus 3 and set it equal to 4. 4 would be the next number I'd like this to be. In order to do that, I'm going to have to subtract 3 from both sides, and that would give me x equals 1. So I put a 1 in here. And when I get the log base 4 of 4, I get 1. This is the point then, 1, 1. Tough thinking. Next one, x plus 3 equals 16. Remember, 16 is 4 squared. That's exactly the number I'd like to use there. In order to do that, I'd have to subtract 3 from 16. That would give me 13. 13 plus 3 is 16. 16 is 4 to the second, and 4 to the second, of course, would be way out there. The last one would want it to be 1/4. In order to do that, I would have to subtract 3 from 1/4, which gives me -2 3/4. So I'm going to use -2 3/4 in order to get this solution, log base 4 of 1/4, which is 4 to the -1, and that gives me -1. So again, the graph would follow this line and right up through here, and of course way out there to 16. It wouldn't be up there, it'd be a little lower. But this is one way to do graphing using the first 3 log rules. I hope this helps you learn more about the log rules, especially the basic ones about the same base. This will be posted, and I hope this has helped you. Thank you.